Hello again, everyone. I'd like to take a couple of minutes to, actually, it'll be a few minutes, to look at question 15 with you from the other day. Um, I had a question from a student about how to specifically solve question C, and I'm assuming if you can't do C, you can't do D either. And the student had specifically told me that they didn't understand the answer in the back of the book. So I went and got the answer in the back of the book. And I can understand why this would be quite difficult to decipher because the writing in the back of the book is very small. I was able to blow it up for the smartboard here. Um, and for question C, it says write n as 4k plus j, where k and j are integers and j is between 0 and 3. Then if j equals 0, I of the n equals 1, blah, 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 blah. That is a very difficult answer to decipher as it's written there. So I decided to take it upon myself to try to figure out a way to make it easier for you to understand what is going on in that answer. So I did this on paper. I decided to just scan it into the smartboard. It might not be exceptionally clear, but I think it's going to be good enough to show you what I did and what my thought process was. So the first thing I did, I didn't start at C. I actually started at A, and it said simplify all of these values of I. Now remember, I are complex values, so I squared is equal to -1. So how does that change as the power to I increases? Now be careful over here. This looks like an I to the -8, but it isn't. That's just the dot for the I, okay? So everything's just increasing by 1 in the power here. And let's see if we can see a pattern, all right? So the first thing I noticed, and I'm going to make this a little bit smaller here. So I did I squared, and I'm sorry about the fuzziness here. This was a scan taken off my phone. So I squared is equal to -1. And then every time you multiply by another I, you're just basically taking the previous answer and then multiplying by i's. It's almost like a recursive function from your ISU, for those of you who have gotten that far, and hopefully everybody has at this point because it was on the assignment. So you're just multiplying by another I. So this means all that happens here is we end up with -I. And then what happens if I multiply -I times I? Well, I times I would be I squared, which would be -1, but it's -I squared, which becomes positive 1. And then I multiply that by I, and I get positive I. And then I multiply that by I, and something happens here. If you look at this value here and this value here, they actually start to repeat. Okay, you get -1, negative I, positive 1, positive I. -1, negative I, positive 1, positive I. So there's a pattern there. So I was like, if there's a pattern, is there a way to exploit that pattern to be able to figure out what future values would be of higher powers, like I to the 99 or whatever they're asking in the question? So I wrote the pattern out, right, just to focus on those 4 things, right? And then I wanted to see, well, okay, what were the powers that associated with that pattern? So this was a power of 2 that gave us -1, a power of 3 that gave us -I, a power of 4 that gave us 1, and I noticed that the pattern repeated it in 4s. It repeated itself, in 4s, right? It's groups of 4. So then I went back to the answer and I'm like, well, that would probably explain why we have 4k here, but what is the relationship, right? Why really is that 4k there? So I decided to continue that pattern all the way up to 49, which is the actual first I to the 49, I believe, is in D, what is the first one that they're asking you to calculate, knowing the pattern. So I just continued all of the powers, right? Knowing that each one of these groups gives us this pattern of -1, -I, 1, and positive I. So 10 is going to be -1, 11 is going to be -I, 12 is going to be 1, 13 is going to be positive I, and then it's going to start over and over again. So I got all the way to 49. Okay, now I'm going to repeat why I went to 49. If you look back here, the pattern, the first one they ask you to simplify after C is actually I to the 48. Okay, so I needed to go to 49 to complete the patterns of 4. Okay, so that's the last pattern of 4 that includes 48. So then I asked myself, okay, well, I need to, just with the 48, figure out which of these values, -1, -I1, or +1, it would be. Okay? Now, if I just divide 48 by 4, because these are groups of 4, what do you get? Well, let me take out my pad here and I'll write it down. Everybody probably already has the answer. What is 48 divided by 4? So 48 divided by 4 is 12. Okay, so what does that mean? Well, that means I'm in the 12th group of 4. Okay, I'm in the 12th group of 4. So if you count my groups, you've got 1, 2, 3, and then 22 would be 4, 5, 6, 7, 8, 9. Wait a second. Oh, I forgot the first 2. Okay, so trust me, it's the 12th group. All right, the math proves that. But 48 isn't at the beginning of the group or the end of the group. Like, what would that 12 mean? Would that 12 mean the 46th position, the 49th position? Like, what does that 12 mean? Right? So I need to somehow figure out what that 12 means. Well, here's the issue. The 12 is in the position that the 1 would be in. Okay? The 48 is in the position of where that 1 would be. But that 1 is within this group of 4, right? So how do I know which position it's in? Which one is it in, right? And I was thinking about that. It's like, well, there's another problem. The other problem is look at what power I started with. That's not the original starting power to this sequence, or right? Like, there's 2 more that are missing. Like, where's power 0 and 1? They're not included because I to the 0 would be 1. And I to the 1 is square root of -1. So those 2 values kind of don't follow the same pattern as all of these do, right? So what I started thinking is, and I mean, I kind of cheated a little bit because I already knew what the answer was, right? If we go back to the answer is 4k plus j. So dividing by 4 takes care of that 4k part, because the 4 is just telling us what group we're in. But what does the j do? Well, what helped me figure this out is that this is very similar to how computer memory works. Computer memory, if you save a file, what happens is there's something called a pointer that's created. And that pointer is an address where the memory that is storing that file is at. When you double click on a file, what it does is it calls up the address of that pointer and repeats what's in that storage address onto your screen. When you delete a file, you're not technically getting rid of that file. You're actually just deleting the address. So the address can be reused by another file and just basically copy over top of what's in the memory. But that file is actually still there in your hard drive. So you may have heard that people can recover files that have been deleted off of a hard drive. That's why. If nothing has been stored over top of that address, then that file is still there. So what is that J, and what am I talking about here? Well, the J is the pointer that's going to tell us which of these symbol or which of these addresses I'm at. So I'm trying to get to this address, right? But the problem is the pattern isn't technically starting here, because there's 2 numbers that are missing. The pattern is actually starting here and going by 4. Okay? So the pattern is actually starting there. And I looked in the back of the book for the answers of what 48, what would I to the 48's answer be? So if we go back, I believe it's in that section. So D, the answer should be 1 for a power of 48. So right here we're doing simplify I to the 48. The answer should be 1. So this answer is supposed to be 1. But J adds or subtracts a number to 4K to move us along that index. Okay? And if you look at what the J value is, if J equals 0, I to the n equals 1. If J equals 1, I to the n equals I. So right here, what is J equals 0? J equals 0 is our first index for our address. And it's saying that I to the n has to equal 1 at that point. Well, if you look at our pattern, I equals 1 is here. Okay, so this is actually J equals 0. And then this is J equals 1, this is J equals 2, and this is J equals 3. So what the J value does is it moves up and down in that pattern to tell us which one are we at. But it's very confusing because this is actually our first number in the pattern we had originally. But because of the fact, sorry, I'm still hiding these. Because of the fact we're not starting at a power of 0, we have to shift our pattern down by 2 so that this would technically be our new power of 0. Okay? So I don't know if that made things clearer. I know I made a couple of mistakes I was talking here because I was trying to sort things in my head as I was explaining it. But that's why we get that answer.